So it is my pleasure to introduce Jeremy Hoffman. Jeremy is the Director of Climate Justice and Impact at Groundwork USA and an affiliate faculty in the L. Douglas Wilder School of Government and Public Affairs at Virginia Commonwealth University, and the Department of Geography, Environment, and Sustainability at the University of Richmond. Jeremy is an award-winning environmental educator and nationally recognized climate scientist and communicator. He was the lead author for the Southeast chapter of the 5th National Climate Assessment, NCA 5, and elected as a fellow of the American Association for the Advancement of Science in 2021. And he's a really nice guy, too. I got to know him a little bit last night. So I'm really excited to welcome our keynote speaker for the morning, Jeremy Hoffman.
Well, good morning, everybody. All right, morning keynote. So I'm so thrilled to be here. I have to divulge a little bit about my personal history. I'm a Quad Cities kid by upbringing, so I grew up in Bettendorf, Iowa, about an hour south of here. And after graduating from Augustana College in Rock Island, Illinois, I went to Oregon State to do my Ph.D. and then landed in Richmond, Virginia, which is where I come to you from today. And so I'm going to talk a lot about the work that I've done over the last, or me and many others, as you can see here. A lot of amazing people have been involved in this work over the last decade, trying to understand the dollars and cents of hyperlocal climate resilience. How do we advance this work at a very hyperlocal level, which is where we know that we have the most tangible effect, at the same time as making the case for why it's important to continue to fund it? So we've been doing some exciting work at Groundwork USA to understand what the dollars and cents are. I'm happy to be sharing a little bit about that with you over the course of this talk. But of course, we do always have to start with a story, as we learned yesterday. And my story is one of childhood photo embarrassment. So I was telling Gina, who is honestly, if you look up the definition of Midwestern nice in the dictionary, I think there's the photo of Gina. I was saying to Gina, I'm actually really thrilled to be showing this picture now because it's not as embarrassing from a fashion sense point of view. Over the course of the last 10 years, this is actually closer to a fire fit, I think, than it used to be. But really the key thing here is the fish, right? So I can show you some other embarrassing images of myself when I thought I was cool as a junior in high school. And then, a couple of years ago, this ties me back to my Midwestern roots. So my family took me up into northwestern Wisconsin, about an hour south of Duluth in Sawyer County, Wisconsin, if there's anybody from that region. Spent my life chasing after this one particular fish, the walleye. My dad used to make walleye and eggs on Saturday mornings when we would be visiting northwestern Wisconsin. And I know where I live now, people are like, ugh. Out here, I saw several people be like, yeah, that sounds good. That sounds pretty good. And so, interestingly, over the time of just my short 40 years on this planet, I had friends from that region start sending me pictures or headlines from the newspapers while I was in graduate school out in Oregon, where it was do you remember, nobody was really catching walleye anymore. We all thought it was just a Friday night fish fry story, sitting there at the bar. The guys would be like, well, I don't really catch the walleye anymore. Well, it turns out it was actually a big issue, a mystery. And I tell people all the time now, I'm like, this is more than just going out and finding a fish that you can eat that you really like. It also shapes the small ecotourism economies of these cities. The availability and stability of those sorts of experiences, like going out and catching a walleye, is one of the things that defines the summertime for many people and the wintertime for some really special people. And of course, once you have a question like this that is a mystery, and decline may be due to temperatures or food, or they live in lakes. Lakes are very complicated systems. So what do we need? We need science. Over the last century or so, the USGS has a bunch of these thermometers in lakes all over the state. And without fail, the only thing that has really changed fundamentally about these ecosystems has been the temperatures. They've warmed up around a degree Fahrenheit. That little star is close to Winter, Wisconsin, which is where my family would go on vacation. My grandparents lived. And what's interesting about science when it comes to this is that you can isolate out all of those little things in that system and disentangle what might be driving a change. So it could be leaf litter, it could be development pressure, it could be sediment getting into the water, it could be the salt content, so on and so forth. The only thing that was fundamentally changing was the temperature. And the walleye really love the cold water. Turns out that their main and more disgusting tasting fish, the big mouth bass or largemouth bass, really enjoys the warm water. So we've seen over the course of the last 40 years a fundamental shift in the ecology of these lakes, so much that several papers have been published on it now, linking this walleye decline into climate change in Wisconsin. You can actually see it confirmed in another outside study. So the Natural Resources Group in Wisconsin did their own study, and then this Canadian group actually confirmed this productivity decline in a few years afterwards. And now it forms one of the key things you can see on the Wisconsin Initiative on Climate Change Impacts website, the impact of climate change on walleye. And so why am I telling you this story? Because I want my 3-year-old niece, who's turning 4 in June, and so excited to see her Uncle Jeremy, I want to take her and I want to make walleye and eggs for her. And what this means, what climate change means, is challenges that ability for me to share a transformational and identity-forming experience with my niece. I think that is what drives me to do this work, is the desire for us to have a intergenerational exchange of experience that allows us to, basically build bonds about places like the natural world. Oh, and where I moved, it's happening too, to the river trout, which is also very delicious. I make my wife trout and eggs now because we don't have walleye in Virginia. But you can see basically the same story playing out over and over again, depending on, regardless of what region you're in. In Virginia here, these are colored by how much a stream has changed in temperature, and the size is related to the amount as well. Without fail, basically every stream where we have long-term temperature gauges in Virginia and throughout the Chesapeake Bay watershed have all tended to rise. And this challenges the habitat for that particular fish. So I basically tell you this story because it links my childhood with my profession and why I show up to the space that I do. Hopefully you also got to learn a little bit about your friendly neighbor to the east and northeast from here. So we know climate change. This will be a quick overview of what we know about the future, where basically climate change has warmed the global average temperature by about 1 degree Celsius, a little bit more depending on the year you're looking at. And largely, the biggest source of uncertainty about the future is what we decide to do in the next couple of years or decades. There's no thing in the climate system that we don't know as much as our actions. So when we look at what the future could hold, the primary thing holding the temperature knob, the thermostat on the global climate system, is us. And so when we look at what the kind of major 2 outcomes that we think, no emissions cuts and substantial cuts in emissions, we're looking somewhere between 1.8 degrees Celsius of climate warming, which multiplied by 2, almost 4 degrees Fahrenheit, as much as 8 degrees Fahrenheit if we do that upper limit. So if we're gonna think, if anybody knows in here, we're going to do a poll by hands. Which one are we closer to? The orange? All right, pessimists in the house. What about the blue? Not a lot of hope either. Oh my gosh. All right, well, good thing is we're getting closer to the blue, but we're also pretty far away from the worst case scenario. So this is good. We can be happy about the progress that's been made, at the same time acknowledging that there is a lot more progress that needs to happen very quickly to bend this curve more so towards the blue. That requires substantial cuts in emissions of heat-trapping gases, mostly brought on by burning fossil fuels for energy. Now, when we take this global picture of what could happen, depending on what we decide to do, and we downscale it to impacts that are relevant to people that live in our region, for example, we have to rely on things like the National Climate Assessment. You heard the mayor say that I was the lead author of the Southeast chapter. It turns out there's a Midwest chapter as well. If you just Google NCA 5, you can look up regional chapters as well as topic chapters. So say you work in transportation or agriculture or the built environment. You can learn a lot about the state of the science of climate impacts in the US from the National Climate Assessment while it's still available online. So get there quick, download the region or topic of choice, and learn more. But I can distill it all down, all 26 or so chapters, I can distill it down into 5 emojis. Basically, without fail, regardless of where you're from, Virginia, Wisconsin, Oklahoma, wherever I heard there was a Kansan in the audience, basically we're going to get hotter, wetter, sneezier, and wheezier, all right? And I wish I could show you charts for all of these things. I originally did, but we can just kind of zoom through some of these things in reverse order. Sneezier and wheezier, already in Virginia, where I'm from, our cars and bikes and surfaces everywhere is covered in a thin yellow sheen of oak pollen. The pollinating is happening. Just the other day, the highest concentration of pollen ever recorded in the state of Georgia happened. The highest amount ever in like 25, 30 years of data, the highest amount of pollen. Now that's probably related to 2 things. One, our springtime temperatures are arriving earlier. Here in the Midwest, it's something like 2 weeks earlier in the year that the last freeze happens on average. Same thing about or so in the Southeast. This, of course, then drives that phenological change, the life cycle events in plants and animals that we can see, like blooming, happening. So that's one thing that's probably driving it. At the same time, there's this feature of more CO2 in the air. What's the one thing that I've heard so much over the last 40 years? CO2 is plant food? Yes, it is, but even to the plants we don't like. So there's a CO2 fertilization process that happens for allergenic producing plants at the same time as them starting earlier in the year. So what does that mean? We have a longer and stronger pollen season. Wheezier in the sense that you're probably not unfamiliar with this because over the last couple of summers, you've probably dealt with some of the worst air quality that the entire country has dealt with, mostly because of wildfires happening thousands, if not thousands of miles away, and that coming along in a river of air subsiding into the region and causing some of the most debilitatingly bad particulate matter pollution of the last 20 or 30 years. I think it's really important, we are living at a time when particulate matter pollution is really, really low. We're in the time of the cleanest air in the history of the country that's being upended by punctuated events related to wildfires. So all else being equal, more wildfires in the future, that means more conditions like that, especially during the summer. So there's sneezier and wheezier, a little bit of a review for you. Let's move a little bit back to the wetter. I live in Virginia, and even though we're in the mid-coast here, coastal communities are dealing with really substantial uncertainty related to sea level rise. So in Norfolk, Virginia, where it's about 60 miles away from where I live, it's the fastest rate of sea level on the entire east coast of North America. Now, this is important for here because people will need to move away from the coasts, and places with a lot of water resources near the Great Lakes make for a really good community to resettle. So that's just one thing that's coming up in the literature. You can read about it in the National Climate Assessment Midwest chapter as well. And so global sea level rise is ice melting on land, the ocean actually warming up. It actually creates, or it fills a greater volume. And then locally, you can have things like land subsidence, or the land kind of lowering in relation to the global sea level signal going up. So you can have places that have much higher sea level rates than the global average. Also, the wetter in the sense that our precipitation events have gotten much flashier. That's one of the things here that I learned about from the Midwest chapter of the National Climate Assessment was the number of water-related transition events. So going from very rainy to very dry, that kind of like whiplash is happening in a lot of different places. And where I live, it's actually driving some of the biggest patterns related to things like wildfire risk, which the Southeast isn't traditionally thought of as being a place where you get a lot of wildfires, but those kind of precipitation patterns changing is one of the things that's really evolving our fire risk. Now also, that precipitation event's getting much more rainy when it happens. As the global climate system warms up, the atmosphere becomes a bigger sponge. And just by being able to wring more water out in a given event, that causes the kinds of things that produce floods, especially in urban areas. We'll talk a little bit more about that in a second. Now, most of my work is not on sneezier, wheezier, wetter, although I have published on those things. Most of my work has been on hotter. So let's dive in a little bit more to what we mean by a hotter climate. Now, that kind of makes sense given we were just talking about global warming, but especially relevant to things like public health and infrastructure are things like heat waves. And almost by every indicator that the EPA tracks on their website for the time being, heat waves are getting longer, stronger, happening at weirder times, and becoming more intense. So this means that they're happening more frequently, they're happening at weirder times of the year, like in the spring or in the fall, later into September, October, November. And the duration, the length of time that we achieve temperatures above a threshold has gone up, and the intensity above that threshold. So everyone knows that a heat wave in Texas is very different than a heat wave in Des Moines, and very different than a heat wave in Portland, Maine. So the thresholds here are very much regional, and I think that's actually what makes it very difficult to talk about heat sometimes, even though we know that extreme heat is the leading cause of weather-related fatalities in the US. So interesting to me. A lot of people don't know this yet. I've been giving talks like this for over 8 years, and this is still a factoid that grabs a lot of attention. Because what do we hear about when it comes to weather-related hazards the most? Hurricanes, at least where I live. I know here it's probably more about tornado risk and extreme cold, especially during the times when you have -30 conditions. But in the Southeast, hurricanes, I mean, you can see hurricanes on the news everywhere because what? We see them from space. You see the eye on the satellite image. You have the name. If you want to have it talked about, give something a name. Everybody in the South remembers names like Katrina, Agnes, Camille, Ida. Now, also, you have the weathercaster that's standing out in the middle of Tampa like, I'm here on Main Street, and whoa! Contrast that to how we tend to report on heat waves. It's going to be a scorcher. Time to get the kids in the pool, to go to the pool. You know, we don't talk about the real risks about heat. We have the Saffir-Simpson scale to communicate about the risks of the wind, sustained wind damage in hurricanes, but we don't have a way of talking about the intensity of a given heat wave. That makes it really difficult because every single one of us, as we know, is different. And our ability to adapt physiologically to extreme heat is very different based on a person-by-person basis. Someone who runs marathons in the middle of the summer here in the Midwest is going to have a very different orientation physiologically to extreme heat than someone that is a very elderly person that lives inside, predominantly in places with like air conditioning. That person goes outside for a very short amount of time. Thermoregulation might be a little bit off. Same thing for young children and babies. They have very difficult time thermoregulating. People that take mental health medications have SSRIs, for example, lower your body's natural ability to thermoregulate. So every single person has a different orientation to the susceptibility to extreme heat. That makes it very, very difficult to communicate and ultimately leads to really significant impacts on our communities. Here, and especially in the Midwest, we didn't learn that lesson better, I think, than in 1995 in the city of Chicago. I was, I think, like 7 or 8 when this happened. But I remember this weekend where temperatures didn't go above or under 100 degrees during the day for like 25 hours or something over the course of 3 days. Temperatures didn't dip below 80. I remember having a great time. My family had a slip and slide, child of the 90s. We had air conditioning, we had push pops, probably dangerous for your health to eat those, but we had a yard party during this extreme heat wave. Meanwhile, 800 people died in the city of Chicago over 3 days. And Eric Kleinenberg, in his book Heat Wave, disentangled the social kind of networks associated with who died. And I want to talk about two things about it: who they were and where they were, all right? Those are two big things with heat. First, who they were. Well, this picture was taken about 12 miles exactly from where I was having a yard party with my family. It turns out mostly elderly members of communities of color on the southwestern side of Chicago had elevated rates of mortality versus similar neighborhoods with kind of the same population, but with much more social network and cohesion than these particular neighborhoods on the southwestern side of the city. Now, also, these areas had much higher mortality than any majority white neighborhood in the same city. Now, also, so who were they and where did they live? The southwestern side of Chicago, which I'll get to a little bit about the history. But these places have experienced substantial disinvestment, targeted disinvestment over many generations, leading to the conditions that, in the social determinants of health kind of parlance, lead to the built environment that's very inadequate for protecting people from extreme heat. You can read this book too, Eric Kleinenberg's Heat Wave. Please do. It's a fascinating book. And largely the same populations that died in this heat wave died in the Portland heat wave from a couple years ago. So tell me how much we've learned really about protecting those same populations, even though we have all the data. Now, we also know heat doesn't heat doesn't do the same thing everywhere. Now, this is where you get to participate again. This isn't about pessimism versus hope this time. This is just, we are all on the magic school bus. I am Miss Frizzle. I'm driving you into this picture, all right? And I'm telling you, you have to do a scavenger hunt. Think in your head. Now, this is the thing. Do not reveal your answer until it is time, okay? Think in your head, where are you going to run to and put your hand on the hottest spot to the touch? Think about it in your head, silently think about it. Where are you going to touch the hottest surface? And on 3, I want you to scream it out so that none of us can hear our individual voices and be ashamed of our wrong answer. No, I'm kidding. On 3, 1, 2, 3. Ah, nice. I love how many different answers are in one voice with that. There's no pattern to that, all right? It's amazing. Now, think in your head again, silently think, where are you going to touch the coolest spot? The coolest spot to the touch. On 3, 1, 2, 3. See, that one was much easier to understand. Shade and trees. I think we have like a biological evolutionary thing about humans just know that under the shade of the big tree is going to be the coolest place. And we probably evolved and that's like ingrained into our DNA to know that. But the other answer was much more complicated. So let's use the tools of science to investigate. I have a forward-looking infrared camera that I can put on my phone and take pictures of the skin temperature of the surfaces in this photo. We can actually reveal how temperature varies across this kind of built environment. So, 1, 2, 3. The brighter colors here are the warmer temperatures. The darker colors are the cooler temperatures. So, absolutely, under the big mature oak tree there in the top left, coolest temperatures, about 87 degrees to the touch. Brighter colors, warmer temperatures, that thick, dense asphalt, pretty newly paved asphalt, very high, like it was, like sticky asphalt. That's the hottest temperature, about 170 degrees Fahrenheit. So you're looking at about 100 degrees Fahrenheit temperature difference to the touch between just 20 feet from each other. Now, other interesting stuff in the same photo, the lawn is as warm as the sidewalk because the lawn doesn't have very good, 1, watering, 2, the roots are very shallow. Across the street from that big lawn is a native plant garden. So I know that there's a lot of people here with native plant kind of related stuff talking about. That has much deeper tap roots that allows it to bring water up from much deeper, allowing it to evapotranspire, plant sweat. Now, other interesting stuff, design decisions like the color of different surfaces, this kind of like black and gray, and then like this white reflective marble. You can see how cool that marble is in relation to the other building surfaces. And then the colors of the cars, right? We all know a black car versus a white car is going to be very different inside when you get inside, or if you have like black leather. And so even for the same material that cars are made out of, the color determines the temperature because of the reflectivity, also known as the albedo. So this principle of like the built environment, basically things that are dark, hard, absorb more of the sun's energy and re-emit it back as heat. More natural things tend to shade surfaces or evapotranspire. We know a lot about this process. And my colleague and I, Vivek Chandas, who's at Portland State University, and now is the principal of Kappa Strategies, LLC. We work together to actually design a way that you can look at the air temperatures in cities, not just those surface temperature maps, or surface temperature pictures. And so we put thermometers on cars, we drive them around the cities. We've done it in like 80 different cities nationwide and a couple internationally. Some of you might have participated in one of the Heat Watch campaigns, I don't know, but I'm very fortunate to have spent a little bit of time working on that here in Richmond, Virginia, with a group of a bunch of really great collaborators. We went out during a heat wave, and in 2017, July, felt like you were walking around outside in someone else's mouth, one of those days. And I, like a psychopath, rode my bike on the mountain bike trails, drank like 6 gallons of water and 10,000 calories of food. This is Ijana. She was a sophomore at Open High School in Richmond when we did this campaign. What's really great about this story is she now is the youth programs manager for Groundwork RVA, and she just recently went to the Capitol to advocate for more funding for public green space. So talk about like watching a young person take on scientific advocacy or scientific work and use it to apply to their life is really great. What we found in Richmond was a 16-degree Fahrenheit difference between the coolest and warmest place at the exact same moment at 3 p.m. 16-degree Fahrenheit is more than some places saw throughout their entire day. Like that amount of change between two places, the variation was much larger than some diurnal variation within the same city, which if you've never been to Richmond before, you have no idea what's going on in this picture realistically, but just know that where there's a lot of trees, nice and cool, where there's single floor buildings, really wide streets, that's where it's really hot. The downtown, perhaps surprisingly, big tall buildings where the streets are very narrow, cast shade on the pedestrian environment. Tall buildings are the most efficient form of shade, causing lower temperatures in our downtown urban core. Fascinating. Now, you might be asking, well, what does this mean for public health? You talked about Chicago, where and who. Let's talk about that. Here's where. We worked with the Richmond Ambulance Authority to look at where they go to respond to heat illnesses over the last 5 or 6 years. Well, this was from several years ago now. But basically, even when you correct for things like population density, it was more likely that you're in a heat island when you experience a heat-related illness that's responded to by the ambulance. This is people calling for help, right? It's not just like admissions to the ER. Now, also, when you disaggregate this information by ethnicity or race, this is where the story gets really interesting, because again, it was where, so we got the story of where. Now, who is it? In Richmond, Virginia, it's about a 45-45 split between white and black identifying individuals in the population. Okay, so it's about half and half. But in these Richmond ambulance responses for extreme heat, 62% are for black residents, while only a smaller 27 to 30% are for white individuals. So that difference in the impacts of this extreme heat is really, really important to shaping and understanding the history as to why that may be. But in summary about this, basically we know that the urban form of a place can tell you whether or not it's going to raise temperatures, things like building densities, the height and the size relative to the streets, the heat from human activities and the heat-retaining properties of the things you build with, balanced by the more natural kinds of things, can lower temperatures. So when we talk about extreme heat due to climate change, we have those heat waves getting more intense, more frequent, but then on top of that, separate and on top of that, we have the design of a place that can further influence the temperatures. It turns out also that this impact, or what's known as the urban heat island effect, actually intensifies the water cycle too. So when we think about hotter, wetter, it turns out the urban form can actually affect how rainfall patterns move and are expressed over cities, with the downtown urban core experiencing more intense rainfall, and to the leeward side, or on the opposite side of where the wind's coming from. In the US, it tends to be the northeastern side of cities tends to be the place, this quadrant, that experiences more intense rain, because you have this heat rising and causing convergence in the atmosphere over these cities. It's called the urban rain island effect. Look it up, it's fascinating stuff. But we also know that urban form is a result of decisions that are made by a very small number of people that affect everything that we all experience when we walk around a city. Every minute of when you walk outside is the result of a group of civic engineers and urban planners kind of saying, this is where this should go, here's what the zoning should be here, and that affects everything you experience in your day-to-day life walking around a city. And it turns out in places like Richmond, this urban planning was rooted in trying to maintain patterns of segregation that had arisen out of the settlement of the city almost 400 years ago. Things like redlining, which we'll talk a little bit more about in a little bit, and our first urban plan, which was done by Harlan Bartholomew in the 40s. He's actually responsible for a whole bunch of urban plans around the country, which is why you have ring roads around cities in the US. Read about him, really fascinating body of work that has shaped the way that we interact with our cities at a broad scale. And these things that happened almost a century ago echo in the present day through where people still live. So in this map, green is individuals that identify as black, blue is where people identify as white. And you can see that the patterns of segregation-related urban planning decisions, which redlining was basically saying, your neighborhood has a lot of dilapidated buildings, the people are immigrants or people of color, they're also very poor, so now we're gonna give them a rating of red, basically allowing them to be denied access to wealth building tools. Then those patterns are reinforced through other forms of urban planning decisions like this one, and as well as urban renewal in the 60s, to give rise to the patterns of continual rooted segregation and patterns of residential sorting, might be a different way to say it, in the present day. Now, why do I talk about that? Because we see the impact of the urban planning decisions on the patterns of heat. Because those neighborhoods that were given this redlining designation are largely the ones that experience the warmest temperatures. And it turns out it's not actually just happening in Richmond, it's actually happening here too. I looked up the redlining map for the city of Dubuque, and almost without fail, the same pattern emerges, where the formerly redlined areas of the city, which is where we're sitting right now, tends to be much warmer in surface temperature pattern, as recognized in the Trust for Public Lands Urban Heat Island data set. So very interesting, the city of Dubuque, I didn't even realize had a redlining map, and it's really fascinating history. You should read about it. Even though there's a very small black residential population, the story of how that was reinforced over the decades since the foundation of the city is really fascinating. Now, we published a paper in 2020 that basically linked these patterns of urban planning related decisions to extreme heat patterns in cities. Here in Richmond, this is a map from Richmond. Those places that are formerly redlined have much more paved over surfaces, many fewer trees, and so they are very warm, just like the patterns you saw in the picture that you identified earlier. And in 94% of the cities that we included in this study, that pattern was observed. So it's virtually without fail, that same pattern happens everywhere. It turns out also that this work influenced a bunch of other stuff that we've been able to do. This map is blue where FEMA underestimates flood risk. And probably unsurprisingly, but still disappointingly, formerly redlined areas have much more flood risk than their non-redlined counterparts. So this is driven by things like the impervious surface and location related to water bodies. It also turns out that those decisions that happened over time, like urban renewal, forced things like infrastructure like the highway interstate system into those same neighborhoods that were redlined in the 30s, producing in the present day differential exposure to things like air pollution. So NO2 is one of the foundational pieces of the air quality index from the EPA. And so what this means basically is that global climate change is a huge, serious issue, accelerating the frequency, intensity, and likelihood of these different climate-related risks. But also, you have things like the local built environment that can either amplify or dampen those particular stressors. And it's very likely the history of your neighborhood has shaped the risk over time through investment or disinvestment, targeted or otherwise. And what this ends up being is either increased or decreased climate-related risks. So I want to tell you in the last few minutes of my presentation about the work that we've been doing at Groundwork USA. We are a place-based, people-centered environmental nonprofit network. We have 21 cities, or 21 trusts or affiliates nationwide. And we do projects that basically take some underutilized land and turn it into a community asset. This includes things like brownfields. In this case, I'm showing you a picture of the HCS Vision to Reality Park in New Orleans, Louisiana, which on the top is the picture from like 4 years ago, and the picture on the bottom right is from last year. Huge transformation. But how do we know that these sorts of investments are returning the benefits that are generally larger than the investment? Or in other words, are we getting more benefit out than we put in monetarily in the investment? So we've been doing these things called benefit cost analysis. You've probably done this yourself, but as a quick review, things like forests and other like natural infrastructure provide some sort of natural capital in the form of an ecosystem function. Trees absorb a bunch of rainwater, for example, leading to a monetary benefit of reduced flood risks. So if you can estimate the infrastructure investment, the capital cost, as well as the cost long-term of maintaining that infrastructure, and value the benefits that you get from these things, you can actually come up with a really great way of understanding the triple bottom line of these ecosystem functions. For example, we know that there are environmental, economic, and social benefits to green infrastructure investments. Things like reduced erosion from planting native plants. We've also got things like new jobs, economic impacts like water utility savings. Some of these things are actually really hard to value in published literature, so many times we're actually underestimating the amount of benefit that we get from these things until we publish direct observations of what those benefits are. But if you want to do one of these things for your own projects, like an urban forestry program, check out FEMA's benefit cost ratio calculator. It's freely available, Excel-based, and you can do your own kind of like, where was it planted, how many trees, and for what kind of ecosystem service are you looking? You can get some pretty widely accepted kinds of impact data from that. So, take you on a quick tour to some of my favorite projects. Let's go to Jacksonville, Florida. Sunny Jacksonville, where they've been working in the North Riverside community, which is a formerly redline neighborhood, directing all of their investment for cool roof renovations in this neighborhood. These cool roofs are significantly cooler than the same kinds of roofs, but not cool roofs in the same neighborhood. We can actually use that same FLIR camera to do this kind of investigation. And it's cooler than the asphalt, no surprise there. This relates to about a 7% reduction in residential energy use, indoor energy use. It's a bit low, but it's probably because for some reason in Jacksonville you can't use an actual white roof. You have to still use some color that's not exactly that. We also installed things like bioswales, which provide direct water-related benefits, as well as less monetarily valued benefits, things like aesthetic improvement and native habitats. When we look at the actual investment, so if we take 50 years of projected benefits and 50 years of projected costs and basically compare those as a ratio, we get this for every dollar invested, we basically get about $2.60 back from these investments in Jacksonville. The cool roofs actually could transform that neighborhood. If we did cool roofs on every residential unit, we estimate that that would benefit the community $400,000 of energy savings per year. For a formerly redline community, that could be a substantial economic benefit. Let's go to Cincinnati. Love Cincinnati. Groundwork ORV put a green roof on a school at Euler School in the Lower Tower Hill neighborhood. These are pictures from space. You can see in 2022, no greenness, 10 times the amount of greenness in the image on the right from September 2023. It's also really fascinating to fly a thermal drone over your investments to see their impacts on the things like the surface temperatures. Those green roofs are about 70 degrees cooler than the artificial turf playground surface nearby at that school. So very interesting. When we actually value out what this does for the people of Euler School, the biggest benefit is the education. It serves as a school classroom setting. So we actually see that this provides over 3,000. The majority of the monetary benefit comes from the education benefit. Let's go up to Elizabeth to a project that I'm really excited about because it takes a place in a very land-challenged place. So Elizabeth, if you're not familiar with it, Elizabeth, New Jersey is sandwiched between Newark Airport, probably the world's worst impression of an airport, and then the Port of Elizabeth, which is one of the busiest ports in the entire world. They're sandwiched between two huge pollution sources. It's also landlocked. They don't have any more land. It's paved over. The majority of the city is paved over. So what they needed to do was to imagine how to use space very efficiently. One of the ways you can do that is with a Miyawaki forest. Basically what this is a microforest. You plant hundreds of trees in the space that would only be about 2 or 3 parking spaces. So we're only talking about 2,000 square feet or something like that. What we see when those trees start to compete with one another, they grow much faster, allowing the benefits to be realized much earlier. And we see things like the soil transform really rapidly, which we can kind of describe a little bit about those bars, but basically the reclaimed soil that we put in these microforests are much more efficient at being carbon vacuums than their nearby mature forests. They're also very efficient from a temperature standpoint. So using that thermal drone again, we see that these microforests are very, very efficient at creating surface temperature cooling, more efficient than the mature 40-year-old trees nearby. These microforests, for every dollar that we spend on them, we get about $3.20 back. This is probably a huge underestimate. We're actually going to be adding in the health-related benefits of trees that are currently being evaluated by our partners at Earth Economics. One of our new microforests in Yonkers, New York, has a benefit-cost ratio when you include the health-related benefits of $20. For every dollar you spend, your community gets $20 back. That is huge, given how very vanishingly little money we tend to have for these sorts of projects. If you can substantiate the fact that a community, especially a formerly redline community, a community with high EJ screen index values, a community with disproportionate exposure to climate risks, are seeing the majority of these benefits, it makes it easier to promote those decisions and to attract more funding to those places. So I wanted to stop there and give us a chance, a few minutes to ask some questions. And ultimately, I'm really excited about what the future can hold for these sorts of very small-scale, hyper-local climate resilience projects. And I'm very thankful. I wanted to just say that all those projects were funded by the Bezos Earth Fund, and we're very, very fortunate to have had that support, allowing us to actually give mini grants out to our affiliates for those projects. So thank you very much for your attention, and yeah, let's talk. Firsthand.
Hi, this is such exciting work, and I'm really curious about, you shared the examples of citizen science and people that, thank you. You shared some inspiring examples of citizen science and people getting involved, and you told one story of one individual who really found her stride through that. I wonder, did you deploy any surveys, or have you tested like what impact engaging in citizen science has on people's attitudes and beliefs about climate change?
I'm so glad you asked that question. So I published a paper in 2020 in the Journal of Museum Education. I was the chief scientist at the Science Museum of Virginia at the time, doing and funded by NOAA to do this work. We did do that surveying of the youth that were included in that project. So Adjana was just one of a team of green team members, all youth from formerly redline neighborhoods in Richmond. And we surveyed them about the pre and post engaging in that project. We called it the Throwing Shade in RVA program. You can find it on my website. And basically what we learned was that these youth before after, we compared their answers to an open-ended question about what is the urban heat island effect. What we found was a 60% increase in the syllabic content of the words that they choose to describe the urban heat island effect, and a doubling of the types and number of unique words. So what we kind of drew from that was that these youth became more scientifically identified. They all took on their own dictionary about why this was important, and then the long-term outcome of watching these youth go through the program and turn into majors in environmental science really shows us that these sorts of committed, socially driven, community-driven kinds of participatory research efforts can be really transformational, especially for youth. It also gave people, adults that were participants tend to say that they think that the cities are doing more about climate change just from participating in a campaign like that. Whether or not the cities actually are doing that, they perceive it as an opportunity for the city to do more. So it gives more faith in civic systems. So those are the two main outcomes that I reflect on the most about the community science work. Thanks for the question. Down here.
Hey, thank you, Jeremy, for your presentation. And a film documentary, Cooked, Surviving by Zip Codes by Julie. The heat wave was real. My statement is, when we talk about redlining, especially in a room, if I may, full of white people, redlining is still going on.
Right.
And so I would like to ask that you give individuals action steps to address that, to be aware that it's really still happening. Now it's, again, zip codes.
Yeah.
I'm from Kansas City, Missouri. I'm in a 64132 zip code. That's the 6th highest poverty zip code in the city. And so, like, it's not a thing of the past, and leadership is really negligent. And so when we get this information, I feel like we're left with what action step can we take to address this? And so if we can share what action steps can we take to make it aware to our leadership that, yeah, redlining is not a thing of the past.
Right.
Because in Kansas City, it's a 100-year plan, and the plan is to come back and fix up the areas to move everybody out. And so this is environmental warfare in 2025.
Yeah, thank you so much for that feedback. And I think, one of the key acknowledgments is, even if your city didn't have a redlining map, which you had to have 40,000 population in 1940, okay? That's basically what the recipe was. If your city didn't have that population or didn't receive a redlining map, that doesn't mean that you're alleviated from these patterns of residential housing, residential sorting, and residential segregation. In fact, cities that didn't have redlining maps tended to have covenants, racial covenants on the deeds to houses. So basically saying people of color cannot buy this house, they cannot live here. So even if your city doesn't have one of these redlining maps, which part of the process is to build awareness around this thing that's called redlining, so go to Mapping Inequality. The Digital Scholarship Lab at the University of Richmond produces an online mapping system. That's how I brought the one from Dubuque up last night. Mapping Inequality. You can read essays, one written by yours truly, about the process, about the impacts, and about policy approaches that we can use to ensure abundant housing, but also secure legacy residents in the neighborhoods that see the transformation. And then talking about it as part of the urban planning process now. My city is going through what is known as a code refresh. Zoning might be one of the most boring things in the entire world that has a direct influence on your day-to-day life. Zoning is the thing that we made up for that purpose. So if your city is going to go through a zoning code refresh or a master plan process, bring these topics of covenants and or redlining up in that process and have conversations about the policies that can reinforce long-term security for the neighborhoods that have been most affected. Because if we don't, we are recreating redlining in the present day through new means. So thank you for that feedback. And I think we can't take any questions, but come and find me. I'm very approachable. Thank you again.
Well, Jeremy, thank you very much for another fantastic discussion. I mean, the discussions that are started in this room have been just wonderful to see. So thank you for everyone for being here. And Jeremy, thank you for that great presentation.